Hey, this is Dr. C. Nice to see you again today. Today we're going to talk a little bit more about the circulatory system in our bodies. We talked about the arteries, we talked about the veins, but there's another component to that circulatory system, and that is the lymphatic system. The lymphatic system. It is a big system. Now, just like our water, in Shrewsbury comes from wells, comes into your house, but then you got to follow the water after, the wastewater. What happens with that? Well, this is the wastewater collection system in our body. There's roughly about 20 liters of what they call interstitial fluid in our bodies. That is fluid that's not in the cells. It's not in the arteries and veins. It's flowing freely in between the cells. That's picked up every day by the lymphatic system. Now, what is the lymphatic system, basically? Well, those blood vessels, the arteries, bring the blood down, filters out around the cells, and then you have the interstitial fluid that comes without the cells, the interstitial fluid. That's the stuff then that the cell has already used, and now they discharge the waste. They took the oxygen, the glucose, whatever the nutrients are, they took that out, and now there's waste, whatever is left. Some of it may be carbon dioxide, the products of metabolism. Some of it may be other things that are waste products as well. And so that goes into what's called the lymph fluid. This is part of the interstitial fluid. That lymph fluid goes into these very thin-walled vessels called the lymphatics. Now, these lymphatics don't have a muscular coating to them, so they don't pump stuff themselves. They depend upon the muscles that are around it to squeeze the fluid back into our circulatory system, into the veins. That's what they do. And so those lymphatics then are very tiny, obviously, around the cells. They go into different channels that are a little larger, and then they eventually drain into the veins. Now, the biggest one, is on that left side of the body. That drains in, it's called a thoracic duct, and that drains into the subclavian vein on that right side. But there's also a smaller one on the left side that drains into the left subclavian vein. The larger one, the thoracic duct, that's the main one. So you can see that the purpose of this system, you might say, basically it's kind of a wastewater system, is to bring the fluid volume back into the circulatory system. That's its main goal, bring it back. But it's also bringing back all those other products as well. And so it acts as a waste improving system too. We're going to neutralize all of the toxins, all of the things that are coming back from the cells as a result of the fluid coming back, gets into your circulatory system, goes into the liver where most of it is detoxified, or may go into the kidneys where we pee it out. One way or the other, you get rid of it. So that is the main reason that we have a lymphatic system. But it's not the only reason, because not only are there metabolic toxins that go into the lymph fluid, but also other things as well. Foreign proteins, viruses, bacteria, all of the other foreign proteins, even pieces of cancer that are called metastatic pieces go into that lymphatic system. Now that lymphatic system will drain up and then begin to go through lymph nodes. We have thousands of lymph nodes in our body, mainly about 700-800 main lymph nodes, which is in back of the knees, for example, in the groins. There are main ones up under the arms, main ones in the neck. So we have these lymph nodes all over the body that act as filters. And those filters filter out all of these other bad products or bad cells or bad bacteria or viruses. They filter them out. But not only do they filter them, but the cells within that system will kill those bad bacteria or viruses or whatever. So there's a lot more to the lymphatic system than just bringing volume back into the body. So let's talk a little bit more about some of these things that happen. Now, back when I was a resident, way back, I did some experiments in a laboratory where we gave animals a toxin. And I cannulated, put a little cannula into that thoracic duct. And the very first thing that happened after we injected a little bit of, say, bacterial products or something like that, foreign substances, the very first thing is that lymph flow suddenly, only 5 minutes later, suddenly increased several-fold. So in other words, we began to see a flow of lymph going up and going back into the system. Now, what else does that lymph flow do? It stimulates then, in all of those lymph nodes going up, it stimulates then the activation of lymphocytes and macrophages. So let's talk a little bit about what these things do. What do they do? Because that lymphatic system, remember, is not just the vessels, the lymph vessels, but it's also the things in the tissues like the nodes and the organs in our body that produce a lot of the cells like the lymphocytes, the monocytes, the macrophages, all of these other cells that help to keep your body healthy. So let's talk a little bit about some of these things in the nodes. Let's talk about, first of all, the big organs, the lymphatic organs in our body. The lymphatic organs are between the external environment and the internal system that we have. So we breathe all the time, we eat all the time, so we obviously have an organ in our throats. The tonsils. Now, what are the tonsils, basically? Well, the tonsils are lymphatic tissue, but they form a ring, and it's called Waldmeyer ring. It's not just the individual palatine tonsils that doctors will take out when they're infected. No. So those palatine tonsils are maybe the size of a walnut when they take them out. They're smaller than that. They may be like an acorn size when they're normal. When they get swollen up, when they're active, they get the size of a walnut. But it's not just those palatine tonsils that are part of that Waldmeyer ring. There's also adenoids. The adenoids are sitting in the back of the throat. They're in the back. They can also swell up, and they can get large enough to partially obstruct the flow of air in and out. Again, they are not the only ones that are there as well. There are other organs, lymphatic organs, that are positioned in a ring around the throat area. And their purpose is to kill any offending agents that come in through the air. That's their purpose. Now, if you look at a tonsil under the microscope, you'd see that it's made up of a capsule, of course, very thin, and it's made up of a number of what they call germinal centers. Now, those germinal centers are typically lymphocytes, B lymphocytes. I'll mention a little bit more about that. B lymphocytes for now. So those germinal centers suddenly get activated with the foreign protein that's in there now, and they swell up. They swell up and produce more B lymphocytes. Now, what do B lymphocytes do? They produce antibodies. Those are the circulatory antibodies, the immunoglobulins. They immediately go and attack any foreign agent that gets into your body. So that's what the B lymphocytes do. And they predominantly are called a B because they come from bone marrow. That's why they call them B. There are also T lymphocytes. They come from the thymus gland. Now, that thymus gland is another gland that's in that lymphatic system. We got the tonsils. Now we've got the thymus gland. Thymus gland sits under the top portion of your breastplate, right underneath. As an infant, as a baby, that thymus gland is pretty sizable. And as we age, it gets smaller and smaller, but it's still there. And it's still producing, if it has to, the T lymphocytes that are in your body. So that is the thymus gland. Now, if you look at that under the microscope, you'll see that there's an outer layer in the gland called the cortex, and then an inner layer called the medulla. And so those are differentiate basically what functions they serve. The inner portion serves a different function than the cortex does in that thymus gland. And so generally, as a baby, as an infant, it produces a lot of those T cells, T lymphocytes, and usually produces enough so you have plenty for practically the rest of your life. But it still can produce more as an adult as well. Okay, so it begins to shrink usually around puberty time, What else is in that organ system now with the lymphatics? We have a spleen. Now, that spleen, we only hear about it because spleens can get injured. It sits in a very protected place. It's under the rib cage on that left side of the body. Right under the rib cage, way in the back. Very protected area. And it's very fragile. It has a very, very thin capsule on it. So it's very easily injured. You'll hear about people who may get a ruptured spleen. Bleeds like stink, so you wind up having to do surgery most of the time for a ruptured spleen. So what does the spleen do? Well, the spleen does two things. Number one, it kills off cells that are dying. Remember, our bodies are regenerating all the time. We're producing new cells in all of the different systems in our body all the time. And so what happens to the old cells? Like me, the old cells. Well, the body has a very efficient way of getting rid of it. It's called apoptosis. What they do is they'll trap a lot of these old cells in the spleen, for example, and they'll use whatever is in those cells so that they recycle whatever is usable and get rid of what's left. Very efficient, too. Very efficient. So even though you think everything in your body is complete, It's regenerating all the time. All the time. So, looking at the spleen under the microscope, you see whitish areas and reddish areas. It's called white pulp and red pulp. Well, they both do different things. The white pulp, that's the thing that produces the lymphocytes. It usually produces the B lymphocytes. And remember, the B lymphocytes are the ones that produce the floating antibodies. That's the immediate response to any infection that comes in or any foreign body that comes in. So that is, excuse me, that's the white pulp. Now the red pulp, that's a filter, and that is the thing that takes care of all those old cells that are coming in to the spleen, and they take the old cells out, use what they can out of the cells, and then you regenerate new cells. Okay, so that's the spleen. We have other organs in the lymphatic system. For example, let's say the appendix. Now, why? What's the big deal about the appendix, we say? Well, the big deal is if you get appendicitis. You can also get appendiceal cancer. But what is the big deal about that appendix? Why is it so small? Because in some animals, that appendix is big. Damn big, some of them. And those are usually in the animals that eat a lot of herbs. They're vegetarians. You don't have to worry about them. They're not going to eat you up. They're going to eat a lot of the plants, but they do develop pretty good-sized appendices. But the appendix, if you look at it under the microscope, it has a lot of lymphatic tissue in it. Now, if you take out the appendix, or you have to sometimes, if you take it out, does that affect your immune system? No, it's a small organ. And the amount of lymphatics in there, in the total picture, is very small. So it does not affect your immune system. So you don't have to worry if you have to have that out. That's not the only one in the intestine, however, in that lymphatic organ system. There's also what's called Peyer's patches. These are lymphatics that are in the small intestine, right in the wall of the small intestine, usually in the lower part of the intestine, so that when we eat a fatty substance, for example, which basically is oil, and remember that oil has to get into the bloodstream to go over to the liver and all, so you need those lipoproteins to transport it into the bloodstream, transport it to the liver. So those Peyer's patches, after you eat a fatty meal, will dilate up because they are getting more of that fatty lymph going into them. So that's another function of the lymphatics. So very good, very good. So by draining then that stuff into the liver and all, that's how we maintain our metabolism. Is that it? Is that it for the organ system? Pretty much. Now we can talk a little bit about the bone marrow, because the bone marrow doesn't have lymphatics in it. The bone marrow has stem cells, immature stem cells. These stem cells can develop into any of those white blood cells, any of them. They can develop into a lymphocyte, a monocyte. They can develop into whatever because they're stem cells. Okay. So the bone marrow predominantly is in, for example, in the big pelvic bones. It's in your bone marrow in your vertebrae. They are in all of the long bones as well. They all have bone marrow. And so they estimate that every day, there's roughly over 200 billion new blood cells made in the bone marrow of an average adult daily. 200 billion every day. That's a heck of a lot of cells, you figure. But you're dying off every day. The lifespan of the cells in your body in the bloodstream, the red blood cells maybe live for 21, 28 days. That's it. So they're constantly being renewed all the time. White blood cells have a very shorter, much shorter lifespan. The blood platelets for the clotting and all, that has a very short lifespan. 10 days for the platelets in your blood. That's why when you take an aspirin, let's say I took an aspirin right now, it would go attach onto all of the platelets at the present time in my body, in the circulatory system, all of them. Now, they only live 10 days. So if I didn't take an aspirin the next day, 90% of them then would have the aspirin on it, but not 10%. And every day they're going to lose 10% more, 10% more, 10% more. In other words, after 10 days, you no longer would have an effect of that aspirin on the platelets. Very simple math. So, and in other words, we're renovating and renewing things all the time. Okay, so where do we go from there? Well, what are the other cells? We talked about the lymphatic system, the blood vessels. We talked about the lymph nodes. We talked about the tissues that are in that system. Now, what about those cells that kill off all of the foreign antigens that come in? Well, we talked about the B and the T lymphocytes. And the T lymphocytes, remember, come from that thymus gland, and the B from the bone marrow. Okay. What other cells are there? Well, there are cells called macrophages. Macrophages. Now, there's two types of macrophages in the body. One are fixed macrophages. They're in those organs, like the spleen, for example. There's fixed macrophages, and their job is to take care of anything that's foreign that comes in, or to take care of the dying cells, natural cells in your body. And then there's circulating macrophages. They may start out as a monocyte, but they begin to change. They get activated into a macrophage, which then will seek out all these foreign substances as well. So those are macrophages. These macrophages will release what are called cytokines, which are chemicals that are designed to swell up an area and to kill. Cytokines. That's basically what the cyto is, the cell. Okay? So they're producing cytokines as well. And they may produce, for example, nitric oxide. They may produce other stuff, which is a killing substance. Now, we also have in our body what are called dendritic cells. Dendritic cells. Now, these are, they present the antigen that may come in, a foreign antigen that comes into your body. Dendritic cells, which start as a B cell, identify it and present it basically to the macrophages which kill it. So that's the purpose of the dendritic cell. They also produce cytokines as well once they're activated. And then finally, there are plasma cells. Plasma cells begin as a B cell as well. And once they're activated, they then can convert into either a memory cell or they can convert into that plasma cell. So plasma cell could be a long-living plasma cell or a short-living plasma cell. There are a couple of different types. But they're all in the bone marrow. Okay, so we talked a little bit about it. But what about that lymph itself? What about the lymph? It's very colorless. It's a distillate, basically, of the bloodstream. No cells in it, generally. Much less protein in it. No red blood cells. But there are some lymphocytes in there. And of course, there's waste products of various types. There's the different lipoproteins. Remember, those lipoproteins are carrying cholesterol, carrying any oily substance, because that oily substance doesn't mix well with the blood, which is a water-based fluid. And so you need that lipoprotein to hold it in so it's not exposed to the blood, to the water, and then it brings it to the liver. So that's in there as well. So that is the lymph that's in there. So as you can see, there's a number of different functions that the lymphatic system serves. Number one, maintaining our fluid level, as we mentioned. It is responsible for the functioning of our immune system in the body. The nodes monitor the lymph, produce the cells and antibodies to protect us. And then the spleen and the thymus will detect. In other words, they monitor the whole system and respond to it. And then it has a role in fat absorption in that small intestine as well. A lot of different functions for that lymphatic system. It's amazing sometimes when you look at the human body and you see all these different functions that are out there. I marvel at it myself. I marvel at those functions that the body can do. Oh, I think Dr. C has had it for the day. I hope you have a very nice holiday season and have a good day.